All right, these notes are going to be on 1.6, solving systems of equations. A system of equations is where a set of two or more equations so basically, like you'll have equation 1, EQN means equation 1, and equation 2, and the solution is the point or points of intersection, because you might have one intersection or two intersections or infinite many. So these are the possibilities. You can have one intersection if you have two lines that has one solution. You can have no solution because the lines could be parallel. You can have two solutions if you have a parabola and a line. Here we have two solutions. You can also have infinite many, meaning it's the same exact line. Infinite many solutions. Now, when I say infinite many, it could be like y equals 2x plus 3, and then you can have the line 2y equals 4x plus 6. Those two are the same exact line. Okay, we're going to first start by solving by substitution. There's three ways. Solving a system of equations. Now there are three ways. The first method that we are using is substitution. Now let's say we have x equals 2y minus 5, and we have 3x minus y equals 5. Now on this one right here, what we're going to do is, if they give you a value, let's say we set x equal to 100. Everywhere you see x, you would put 100 there. Here they told me what x equals. X equals 2y minus 5. This is actually going to get plugged into right there. So let's go ahead and let's put the steps on the side. So the first step is we have to solve one of the equations, one equation for x or y. It's already done for me. It says x equals. So since that's already done for me, I'm now going to plug that into the other equation. So now you're going to plug into the second equation. So now instead of writing a 3x minus y equals 5, I'm going to replace the x with this 2y minus 5. Now, if you notice, the only variable here is just y now. So I'm going to go ahead and I'm going to solve for the variable. So let's go ahead and distribute. So 3 times 2y is 6y. 3 times negative 5 is negative 15. Do not distribute the 3 to the negative y because that's on the outside. You're only distributing the 3 into the parentheses. Okay, here's the equal sign. What I do to one side, I do to the other. On the left side, these are like terms, so those get combined. So do not add y, because they're on the same side. So they're actually, you just combine them. So then 6 minus 1, there's a 1 here, you just don't see it, is going to be a 5y. So this is 5y minus 15 equals 5. I'm still solving for y, so I'm going to go ahead, the opposite of minus 15 is plus 15. So 5y equals 20, and then the last step is to divide by 5. I'm not done though, because your solution is going to be a coordinate point x and y. That's only the y. So now that I found the y, I'm going to plug the variable, plug the value of the variable into one of the original equations. Now, it doesn't matter which one you plug it into because there's only one point where these cross at. I'm going to go ahead and I'm going to just plug it into the top one because that's just, it looks easier. So I have x equals a 2y minus 5. You are plugging in the y into there. So I'm going to erase the y and I'm going to plug in the number 5. Oh, that's 4. 20 divided by 5 is 4, not 5. So now here, order of operations says multiply first and then subtract. The last step is to write your solution, as a coordinate point. It has to look like this. So it doesn't matter that I solve the 4 first. The x coordinate goes first, and the x is the number 3, and the y is the number 4. Now you could go back and check your answer by plugging this into here and making sure the left side equals the right side, and plugging into here and making sure the left side equals 5. Let's go ahead and do another example. Y equals x squared minus 8x plus 5. Y equals x plus 3. Now here we have a parabola and a line. So on a parabola and a line, you can have 0 solutions, 1 solution, or even 2 solutions. Now I am going to solve this by substitution because I have a y equals and a y equals. I don't really have to do step number 1 where it says solve one equation for the x to the y. But the second one says plug into the second equation. Well, but guess what? These two, because it says y equals and y equals, I'm just going to set those two equal to one another. So I have an x squared minus 8x plus 5 equals x plus 3. When I see an x squared is a clue that you will need a factor. Now we learned factoring in math 2. Now, but before we can factor, we need to set this equal to 0. So I'm going to go ahead and I'm going to move the x to the other side, and I'm going to move the 3 to the other side. So here I have an x squared minus a 9x plus a 2 equals a 0. Now, when you are factoring, this cannot be factored. Okay, so when we are solving, first we're going to try to factor. If we can't factor, you can try to complete the square. On this one, because that's an odd number, if I complete the square, I'm going to be left with a fraction, and I'm going to try to stay away from that. But the quadratic formula actually works for all of these. So the quadratic formula is x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. I'm going to solve this by the quadratic formula. So right here, this is ax squared plus the bx plus the c. There's a 1 here you just don't see. So the a value is equal to 1, the b value is equal to negative 9, and the c value is equal to 2. So I'm going to write down the quadratic formula, negative b plus or minus square root b squared minus 4ac all over 2a, and I'm going to plug in my numbers. So the b is a negative 9, so I'm going to erase the b, and I'm gonna plug in a -9 there. There's the B, I'm gonna erase it and plug in a -9. There's an A and a C, and those are being multiplied. So the A is 1, the C is 2, and the A is 1. A negative and negative makes that a +9. 2 times 1 is 2. And then right here, I have a -9 squared. That's going to be the exponent. So that's going to be 81 minus 8. And 81 minus 8 is 73. 73 cannot be broken down. So my answer, I'm going to split it because there's two of them. There's a plus and a minus. I need to find out what x equals 9 plus square root of 73 divided by 2 is. And I have to find out what 9 minus square root of 73 divided by 2 is. So let me grab my calculator. I have 9 plus square root of 73. Oh, wait. 9 plus square root of 73. And then I'm going to divide that by 2. So that's 8.772. And then I'm going to type in 9 minus square root of 73 and divide that by 2. So here's one of the x solutions. Here's the other x solution. So once we found the variable, we have to go back and we have to plug in the value into one of the originals. On the originals, I'm going to plug it into this one because that one looks easy. So first I'm going to plug in this one. Y equals x plus 3. So this is going to be y equals 8.772 plus 3. So here y equals 11.772. Now you're going to write your point as a coordinate point. So right here, x is going to be 8.772, comma 11.772. That's one solution. Now I'm going to plug in this one into that same equation. So y equals 0.228 plus 3. So y equals 3.228. So this point is going to be 0.228, comma 3.228. So that is a method of substitution. The next method I'm going to show you is elimination. So on elimination, we need to make sure our x's, our y's, and our equal sign is lined up. If it's not, you can go ahead and rearrange them to make them lined up. So I'll put the steps here. So the first step is to make sure the x, the y, and the c equal are lined up. Next, we are going to make one set of these cancel out. So you're going to make one set of variables, and in order for them to cancel, they need to be opposites. Make one set of variables opposite of each other. So basically, like one has to be a positive 3x, one has to be a negative 3x. Or like right here, I have a positive 2, so that would have to be a negative 2. Sometimes you have to multiply both equations. Sometimes you only have to multiply one. So right here, what I'm going to do is I'm going to go and I'm going to make the y's cancel out. So that's already a positive 2y, so I need that to be a negative 2y. So the only way to make that a negative 2y, it's already negative. I just have to multiply all of that by the number 2. So I'm going to keep the top equation the same. But the bottom equation, that's going to be a 6x. That's going to be a negative 2y. And that's going to be a negative 10. You are now going to add up the equations. So I'm going to add up the equations. There's a 1 here, you just don't see it. 1 plus 6x is 7x. Positive 2y, negative 2y, those eliminate. And then negative 4 plus 10 is negative 14. Next, solve for the variable, because if you notice, you only have one variable now, and that's going to be the variable x. That's the whole purpose of me multiplying this by 2, is so that the y's eliminate. So now when I divide by 7 to both sides, I get x equals a negative 2. And just like before, I'm not done. I need to plug that into one of the original equations. So plug the variable value into one of the original equations. It doesn't matter which one we plug it into. I'll go ahead and I'll just plug it into the top. That says x plus 2y equals negative 4. Make sure you are plugging the negative 2 in where the x is at. So where the x is at, I'm going to erase it and plug in a negative 2. And now I go back to solving a two-step equation. You are solving for y. So don't get rid of the times 2. You're going to get rid of the subtract 2. And opposite of subtract 2 is to add 2 to both sides. And then the last step here is to divide by 2. Now write your solution as a coordinate point. So the x is negative 2, the y is negative 1. And once again, you can go back, plug in x and y, make sure you get a negative 4, plug in x and y, make sure you get a negative 5. The last method for solving a system is by graphing. And to help us out here, we're going to go ahead and we're going to use Desmos. So y equals negative x plus 4, y equals 3 over 2x minus 1. Actually, these ones are pretty easy. You can plug them in on Desmos and see the point of intersection. I'm going to go ahead and I'm just going to graph these. Let's go over graphing really fast. So you have y equals mx plus b. That is your y-intercept. So 1, 2, 3, 4. And your slope is a negative 1, which is going to be down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. So this right here is the line y equals negative x plus 4. On this one, your y-intercept is at negative 1. And your slope is positive 3 over 2, so that's up 3. So 1, 2, 3 over 2, up 3, 1, 2, 3 over 2. And your point of intersection is this point right here, 2, 2. And we're done. Let's go into some graphing inequalities. This is the last part of the notes. Keep in mind that if you have a less than or equal, less than or greater than, without the line on the bottom, those are going to be drawn with dashed lines. Which means not included. And if you have a less than equal to or greater than equal to, those are going to be drawn with solid lines, which means included. We're going to go ahead and we're going to sketch the graph of the set of all points that solve each system of linear inequalities. So this is different than in the 1.5 notes, because now you want all the points. So now we're looking at the y values, where before we were only looking at the x values. So here's one line, here's another line. Let's go ahead and let's draw the top ones right here. I'll draw y plus 2x is less than 10. I need to solve for y here, so I can put in y equals mx plus b form. So I'm going to subtract 2x to both sides. So y is less than 10 minus 2x. So here's my y equals, there's my mx plus my b. Remember, m is the one next to x. So your y-intercept here is going to be at 10, but your slope is going to be a -2. Before I draw the graph though, you see that's the less than symbol without the line on the bottom. So right here, you're going to draw this with a dashed line. And then that's the less than symbol because it makes an L for less than. So less than, when we think of less than, do we think of up or down? We think of down. So what's going to happen is where our line is at, since that's the less than sign, we're going to shade down. So let's go ahead and graph this. I got to go all the way up to 10. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So my y-intercept is at 10. And then -2 means down 2 over 1. 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 So I'm going to draw this with a dashed line. And when I mean shade down, so here's the graph. Don't go up, you're going to go down. And I'm going to shade it really, really light. Because what's going to happen is it's going to overlap each other. I just shade one going up and down, the other one I'll shade side to side, so it's easy to tell. I'm going to go and draw this graph now. X minus 2y is less than or equal to 8. That is going to be with a solid line now, because there's a line on the bottom. We have to solve for y, so I'm going to go and I'm going to minus x to both sides. So -2y is less than or equal to 8 minus x. Now, when you divide by the -2, whenever you divide by a negative or multiply by a negative, that inequality symbol is going to flip. So it's no longer less than equal to, it's greater than equal to. And then 8 divided by -2 is a -4. And then right here, a negative and negative makes that a positive. There's actually a 1 here, you don't see it. So that's actually a 1/2 x. That 2 has to go underneath both terms in the numerator. So this is going to be with a solid line. That does not make an L for less than. So that is the greater than symbol, and greater than means to shade up. And look at the symbol at the very end. Don't look at the symbol at the beginning. Look at the symbol when it's a y equals mx plus b form. So here's my mx plus my b. So my y-intercept is going to be at -4. Then I'm going to go up 1 over 2, up 1 over 2. So right here, that's going to be a solid line. And now I have to shade above the line. So I'm going to draw in a different direction. Your solution is not these 3 sections. It's only the section that overlaps. And it overlaps starting right here at the intersection. It overlaps only in this region. So now I have to go back and I have to erase this part because this part's only true for one equation, not the other. And down here. So the only solution to this is only this left side. Okay, that concludes our notes. However, I want to do one problem from the homework. This will help you out on the homework. It's a word problem. Enterprise rental charges a flat fee of $35 plus 50 cents per mile. Hertz rental charges a flat fee of $50 plus 30 cents per mile. So one will be cheaper if you don't drive a lot. The other one will be cheaper if you drive a lot. When will the cost of enterprise be the same as Hertz? Now, if you look at it, a lot of people are like, oh, well, that's only $35 to begin with. So let me get that one. But if you're going to drive a lot, your miles are cheaper with the Hertz. So we need to find out when these are equal. I'm going to go ahead and I'm going to let X equal the miles. And I'm going to let Y equal the cost. So first is enterprise. So they charge a flat fee of $35. So the cost here is going to be 35 plus. Now, when it says 50 cents per mile, the word per means multiply. And then remember that mile is going to be X. So that's going to be a 0.50X. Hertz charges a flat fee of 50. So that's just going to be 50 plus. Now they're going to charge 30 cents per mile. I'm going to go ahead and I'm going to solve this by substitution. I'm just going to set these two equal to one another. So I have 35 plus 0.5x equals 50 plus 0.3x. I'm going to move the x's to one side, so I'm going to move the smaller one. So I have 35 plus 0.2x equals 50. Now I'm solving for x, so I need to move the 35. And now I'm just going to divide by 0.2 to both sides. And that equals 75. And keep in mind that X represented the number of miles. So the question says, when will the cost of enterprise be the same as Hertz? Well, at 75 miles, it will be the same. The cost will be the same at 75 miles. And that concludes the notes.